Alright, we are moving to chapter 12.6, which is about permutations and combinations. We're going to talk about permutations today. Tomorrow we'll talk about what combinations are and go from there. While I'm talking about this, go ahead and write this information right here. The first thing you got to understand about what a permutation is, it's just a fancy word for an arrangement of objects. In other words, if I had three letters A, B, and C, there are 1, 2, 3, 4, 5, 6 different ways that I can arrange all three things. In this permutation, ABC is different from ACB, is different from BAC, and so on, which is what makes it a permutation. Alright, so again, the key thing for you to remember over the next few days, actually up until the test, is that a permutation is where the order of the objects is important. The fact that A is first and C is last means that this is different than everything else here in that set. Alright, and also the thing that you're going to start using today, because we're not going to talk so much about permutations today, but that arrangements can be planned by multiplying options in blanks, which we're going to talk about what that means pretty much right now. Problem 1 says you're shopping for a new car. It comes in 4 different colors with 7 different interior patterns and an option for 2-door or 4-door. How many different ways can you design the car? Here's what you have to understand. You're talking about how many different ways. It means how many different options can you choose. The first thing you ought to understand is it says we have 4 different colors, so that's a decision because we have to choose a color. 7 different interior patterns, so we have to choose an interior. And then you have 2-door or 4-door, so you have the door style. And so all you have to do when you're counting your decisions that you can make is you simply put how many choices you have. Notice in the first blank there are 4 different colors, so you put the number 4 because there are 4 things to choose from first. You are going to multiply that by the number of interior patterns, which is there are 7 different interior patterns to choose from. And then in terms of door options, there is 2 different options. Again, you have to read that. There is 2-door or 4-door, which means that there are 2 different options, and all you have to do to find out how many ways there are is to multiply 4 times 7 times 2, which is easy enough to do in your calculator, to find out that there are 56 different arrangements that you can choose for your car. Again, it is not a difficult thing. You just have to understand in terms of this section, in terms of statistics, probability, and all that, that whenever you make a choice and you have a series of choices, just put blanks for every choice and then fill out how many options you have at each choice, and that will give you the number of total decisions that you have to make. Alright. Looking at problem number 2, talks about how you have 35 books for summer reading. If you're going to choose one different book each week to read, how many different ways can you choose one per week for 6 weeks? So here in this problem, what we are looking at is that we are making 6 choices because we're talking about 6 weeks worth of work. Again, you know you have 35 books, but there are 6 weeks worth of work. So week 1, week 2, week 3, week 4, week 5, and week 6. Again, there are 6 choices for me to make. I have to choose one book per week. And here is where your decision comes in. How many books do I have to choose from in the first week would be 35 books. But here's where you have to think. If I chose a book this week, I'm obviously not going to choose that same book the next week, which means that the next week I don't have 35 choices, I have 34 choices because I've already read one book. Now I have 34 books that I haven't read. The next week I am going to have 33 choices because I've already read 2 books. Just like the next week I'm going to have 32 choices. Just like the next week I'm going to have 31 choices, and the last week I'm going to have 30 choices. Again, talking about decision making, you have 35 books to choose from and you're making a choice for 6 weeks. You have 35 times 34 times 33 times 32 times 31 times 30, which is a lot of different ways to do it, but again, that's all you have to do. So you simply type that in. Which gives us a whole bunch of choices. That looks like, let's see, 1, 2, that's a million. So 1,675,200 different ways that you could do that. That is what that is. But again, it's a whole bunch of different ways because you have so many different books and you're talking about 6 weeks. Again, this is the different number of ways that you can read those 6 books. We're going to talk tomorrow about something that kind of simplifies this a little bit and a question that kind of confuses people a little bit, but for right now, just understand again, we are making basic choices of, I have 35 books to choose from, 34, 33, 32, 31, and 30. Problem 3 says there are 7 different types of forks and 5 different types of spoons. How many different spoon and fork arrangement can be made? You have to choose 1 fork, 1 spoon. Think about it. I've got 7 different types of forks to choose from. I've got 5 different types of spoons to choose from. Those are my only 2 choices. I simply multiply those out, and I have 35 different spoon and fork arrangements that I can use. Again, making a choice, you have to ask yourself in these questions, how many choices am I making? I am choosing a spoon, I am choosing a fork. That is 2 different choices that I am going for, and that is that. Write this real fast as we kind of move on to the next part and get ready to wrap this up. When randomly selecting, sometimes you have to consider whether you are replacing something. So if I told you I am pulling names out of a hat for a drawing and your name is in the hat, the question whenever someone is drawing something is, after I select your name from the hat and you win a prize, does your name go back in, or does your name stay out and you can no longer win again? If it is with replacement, it means that I choose your name, you might win the first prize, and if I put your name back in the hat, you could also win another prize later on, or another prize after that. If it's not replacement or no replacement, then it means that once you've won once, then you are done. There's no way you can get selected again, and that is important because of the number of decisions that you have on the next option or next picks from what's going on. So looking at this, this question here has a couple different ways that you can look at it. And the way it looks is, again, if there are 13 red chips, 12 blue chips, how many different ways can you select 2 reds and 1 blue if the chip is not replaced after drawing? So again, your first question is, how many choices am I making? I am selecting 2 red chips, that's 2 decisions, and 1 blue chip, that is 1 decision. I don't need the numbers yet, I need the number of decisions. So figure out your number of decisions and put a blank for every decision. Now you simply think, how many ways can you select 2 red chips? So first red chip is going to be 13 different chips to choose from, and it says the chip is not replaced. So if there are 13 chips in a bag, 13 red chips in a bag, and I pull that red chip out and it's not going back, you have to think how many chips are still left, or red chips that is. And if I took a red chip out and did not put it back, there are no longer 13 red chips in the bag on my second draw, there are only 12. So again, this is red, and this is blue. Well, how many blue chips do I have to choose from? If I haven't selected any out yet, I still have 12. So again, to choose the first red, you have 13 to choose from. But I did not put it back. I did not replace it, which means that after I took the 1 out, I now have 12 red chips left to choose from. And in the beginning, as always, I still have 12 blue chips to choose from. So these numbers multiplied will give me what I'm looking for. So 13 times 12 times 12, which is 1872. 1,872 ways that I can possibly pick a red, and a blue with these numbers. If the chip is replaced after drawing, again, we are making 3 choices. The difference between that is now you have 13 chips to choose from, but you put it back, so you still have 13 red chips to choose from and 12 blues. So again, if it's replaced, it means I took a red chip out, I put it back, which means that there's still 13 red chips to choose from. Again, I put it back, and then there are 12 blue chips to choose from. And so instead of 13, 12, 12, it's 13 times 13 times 12, which is 2028. So you can see how the answers would be different, and it depends on whether you are replacing or not replacing. This would be with replacement. This would be without replacement. Again, not replacing means that you are not putting it back into the hat to be pulled from. You are keeping it as it is, which means as you draw, every time this number is going to go down 1. As you draw, every time this number is going to go down 1. If I'm replacing, then the number should stay the same. Alright? And then as we get ready to wrap this up, you notice that we are having numbers go down and go down. A factorial is simply the product of all numbers from n to 1. So n represents what the factorial is. If you want 5 factorial, which is just a symbol right here, this is 3 factorial. 3 would be the value of n, so 3 factorial would be the product of numbers from 3 to 1, which means 3 times 2 times 1, which is 6. That is 3 factorial. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 40,320. I do not think that we would like to find something like 15 factorial, because 15 factorial means I have to do 15 times 14 times 13 times 12. Notice how many buttons we have to push. I don't think there has to be an easier way for that, which is why you need to make sure you have this written in your notes. Probability is what we're dealing with, and it's in the math button. So if I want to know what 15 factorial is, I simply hit math. Notice there's your probability part, so you can move arrow over to that and you see your factorial symbol there. So what you have to do is type the number you have, which is 15, and then math, choose the probability, oops, clear that, 15, math, go to this part here, don't hit anything yet, and then scroll down to number 4 or hit 4 and hit enter, and you notice that 15 factorial is what you see there, which gives you a very big number. That's why I said you don't really want to do 15 times 14 times 13, whatever. So bottom line, you're going to have to know how to do this on today's work, so make sure you know how to find that. If you don't know how to find that later, make sure you say something to me so I can try to help you. But in order to evaluate, and this is going to be a question you're going to see today as well as on the test, in order to evaluate 11 factorial, you simply type 11, math, go over to the probability version of your, because notice how this moves across. These are different menus, and we want the probability menu. Then select the factorial option, and then when you hit enter, you see that it is 399,16800. So 39,916,800 is what 11 factorial is. So go on to Math XL and begin answering all the questions about this stuff here. Again, if you get stuck, please make sure you speak to me. This is only going to be done for 2 days, or actually it's going to be done all week, but every day is going to get tougher than the day before, so make sure you understand how to make your selection blanks and set those things up so that you can get them done the right way and understand what's going on. Speak up if there's any issues. Other than that, good luck.